When a sun-like star runs out of fuel, it doesn't fade quietly. It aggressively boils, sheds its outer layers, and violently rips apart. We can observe the aftermath in the Cat's Eye Nebula, also known as NGC 6543. NGC stands for the New General Catalog, a standard directory of deep sky objects. This nebula is a 1,000-year-old fossil record of a stellar execution. Early astronomers classified these as planetary nebulae because their round shapes resembled planets in low-resolution telescopes. A planetary nebula is an expanding shell of gas ejected by a star during the final stages of its life. Hubble Space Telescope data destroyed the assumption that these were simple, uniform spheres. The Hubble Space Telescope is a space-based observatory that orbits Earth, capturing high-resolution images in visible, ultraviolet, and near-infrared light. Its images exposed a chaotic core filled with high-speed jets and dense knots of gas. Beyond that chaotic core, Hubble revealed a bullseye pattern, 11 perfectly concentric rings surrounding the center. These unexplained rings provide the data necessary to reconstruct the exact physical forces that tear a star apart. To see the full scale, we need the Euclid Space Telescope. The Euclid Space Telescope is a wide-angle mission designed to map the geometry of the dark universe by observing billions of galaxies. Euclid's infrared view reveals a massive halo of gas extending far beyond the nebula's core. Combining Euclid's massive scope with Hubble's visible light data allows astronomers to map the complete timeline of the star's decay. This 3D wireframe corrects a geometric misconception. The flat rings are an optical illusion. A cross-section reveals they are brightly illuminated outer edges of nested bubbles. Each bubble contains the mass of all our solar system's planets, ejected in rhythmic pulses at 1,500-year intervals. These ancient, rhythmic ejections set the stage for a violent disruption that forged the chaotic core we see today. A thermal anomaly found in the inner halo contradicts everything standard models predict about how dying stars heat surrounding gas. This chart maps the 8,000 to 9,000 Kelvin baseline of the core nebula. Moving outward, the stretched ellipsoidal envelope burns hotter, between 11,000 and 12,000 Kelvin. Furthest from the star, the outer halo peaks at 14,000 Kelvin. The gas gets hotter as it expands. Stellar ultraviolet radiation is physically incapable of creating this secondary heat spike. Ultraviolet radiation is a form of high-energy light with wavelengths shorter than what the human eye can see. The only mechanism that fits is hydrodynamic shock. Hydrodynamic shock is a violent transition in pressure and temperature that occurs when gas moves faster than the speed of sound through its medium. The process begins with the dying star emitting a slow, dense, pulsating stellar wind, creating the older shells. 1,000 years ago, the mass loss abruptly changed. The star fired a fast wind at 80 kilometers per second that violently rear-ends the slower, older wind. This supersonic rear-end collision generated the shock waves that carved the shells and produced the extreme heat signatures we observe today. The Cat's Eye Nebula is a frozen, observable snapshot of kinetic violence. Merging Hubble's precision and Euclid's scale transformed abstract hydrodynamic theories into proven, observable facts. This discovery points directly toward the ultimate timeline of our own solar system. In approximately 5 billion years from now, our own sun will undergo these exact same violent, pulsating mass loss convulsions. Decoding the fossil record of the Cat's Eye provides a look into a cosmic mirror, the glowing, concentric tombstone that will one day mark our own existence.